On this episode of Global Topic, I'll have a conversation with Bill Nelson, who's the Vice President of Business Development at Axiom Manufacturing, which produces the Schmidt abrasive blasting equipment line. Bill and I will have a conversation on the topic of industrial surface preparation equipment safety. Welcome to Global Topic, the go-to series for the global corrosion and protective coatings industries, exclusively here on YouTube. In this series, you'll find technical content, information, and the latest industry news and events. And now for today's topic. Hey, Bill, welcome to Global Topic.
Thank you for having me, Jim.
Hey, if you could, for the viewers, if you could go through a little bit about your background and talk about Axiom Manufacturing.
Okay. Well, I specifically currently am a vice president over product development and business development. I've actually been in the same building now, I think 32 years. I've started with the original Schmidt family-owned business whenever it was called Schmidt Manufacturing, and we went through some roll-ups, some breakdowns, and today, well, I say today, as of 15 years ago, we became Axiom Manufacturing. Axiom is the worldwide producer of the Schmidt line of abrasive blasting equipment. We concentrate on bringing a higher level of efficiency and a higher level of safety to the operators in quite frankly, a hazardous environment. And I personally think we're doing a pretty good job with our product offerings and new product development that we try to bring out every year to enhance their opportunities in the marketplace.
I know personally myself, I've had several opportunities to see your equipment line in operation, and also the focus that you have as a company regarding safety related to the equipment. So, Bill, for those watching this episode that have a very limited or probably no knowledge of abrasive blasting or blast cleaning equipment, how important is blasting equipment for surface preparation and cleaning when it comes to the success of a protective coatings project?
It's a critical element that, and quite frankly, that's a great question, because I personally don't believe that enough thought is put into it. I mean, let's face it, protective coatings by and large are designed to adhere to a surface that's free of foreign matter, no corrosion, mill scale, atmospheric conditions and such. And most of those coatings also require a specific surface roughness or anchor profile, if you will. Most coatings don't like to stick to a smooth surface. And this is where blasting, actually comes into play. It's simply an erosion process where the abrasive is propelled at a target with compressed air to impact that target with a certain amount of energy to not only do the cleaning, but also do an erosion process on the surface to create that anchor profile. How much energy is that's delivered to that surface with the abrasive is what creates either an efficient or an inefficient blasting process. And of course, there's a wide offering of products in the market. So it's up to the operators to really understand what it is that they're getting into. It's an expensive process. The energy required to do this is immense. That compressor is a large, high dollar, expensive unit to run. It's going to eat electricity or diesel all day long, the entire day. And the selection of the equipment needs to be taken into consideration to get that high dollar energy to the surface. In other words, some equipment offerings out there are limited in how much free flow of air they can have across their system, which means that you're paying for energy out of that compressor, but you're not delivering it to the nozzle where the work is being done. So the selection of the equipment should certainly take into account the ability for it to convey that compressed energy all the way to the nozzle where the work is done. Abrasive metering is also a huge element in this. You know, there's because this is an old industry, there's still a large misconception about abrasive metering. A lot of the blasters of old, they want a lot of abrasive coming out of that nozzle because that's how their daddy taught them and that's how their granddaddy taught them. Well, the technology has changed today to give them the ability to what we consider proper metering of that abrasive. If that equipment can't restrict the flow of that abrasive into the energy stream, you're simply putting more abrasive into that hose than what the nozzle can utilize at the substrate. So if you're running too rich, too much abrasive, you actually are having particles come out and strike the surface, and then you're having the particle behind it impact that first particle. So at the surface, you have particle on particle, collision, creating dust and not getting to the substrate that you're trying to clean. And that in itself is just a cost. Abrasive is expensive today. Back when this was started, it was all sand. Today with the garnets, with the manufactured abrasives and all, it's an expensive element to it, and not just the acquisition of the abrasive, but the disposal of the abrasive. You don't leave it out in the yards anymore. You have to pick it up and haul it off. And, the industry tells me that, for every dollar of abrasive you spend on the acquisition of abrasive, you're really talking about half of that for the disposal by the time you use the labor and the trucking and the haulage and the disposal fees. So the selection of the equipment is a critical element in developing an efficient and safe blasting environment. So you're utilizing a vast majority of the energy and you're minimizing how much abrasive that is being consumed and therefore thrown away.
Very, very interesting. Very good information. As everyone, knows in our industry, nearly 80% of coating failures on projects, they're directly attributed to improper surface preparation. And, so my next question would be, when it comes to an operator and a loader, those crew members on the other end of a blast, hose, when it comes to their roles, what responsibilities does the crew have when it comes to safety?
The pot tenders are a critical element to the overall operation of the systems. And when I say system, I'm not just talking about the abrasive blasting equipment. I'm talking air compressors. I'm talking every hose. I'm talking after coolers, blast hoses, couplings. Everything is related to itself. So let's not talk about blasting equipment. Let's talk about the systems. Those pot tenders have a critical role in that. And they have to understand the inherent dangers with abrasive blasting, with compressed air, with the abrasive itself. Not only is there a tremendous amount of energy in every hose and every fitting, that abrasive is also quite heavy. Granted, years ago it was sand, 100 pounds a cubic foot. Today, garnet is around 140 pounds a cubic foot. So these bags, pallets, sacks that are being just moved around from location to location is a safety hazard in itself, just due to the weight and the equipment that's required to handle that weight. Going back to the system, air leaks are a tremendous safety hazard. And frankly, I see them all too commonly. It's an air hose that has a leak. Well, what happens when that leak becomes big enough to pick that dormant abrasive up off of the ground, the spillage, and propel it up into the air where now it's in, at eye level with people. And it's the only people out there wearing the full on PPE, blast hoods, are the blasters themselves. It's not the people that are back tending the pot. It's not the coworkers that are surrounding that equipment. It's the entire job site that is at jeopardy just from simply an air leak not being properly addressed. So back to the pot tenders. They're also responsible for having an intimate knowledge of the overall systems and the dangers that can be, that can develop on those job sites. Those men have to understand what forces are truly at play inside every hose, every fitting, every vessel, within that system, which means they have to be fully aware and comfortable with how to pressurize that equipment, how to depressurize that equipment, how to make that equipment safe for either maintenance or refill, and then know how to safely re-engage that system, repressurize that system, and put it back into operation so the work can continue. That's a tremendous amount of responsibility on the pot tenders. And, you know, most of the time the pot tenders are kind of new hires, and they're given a brief description of what this equipment is, and then they're put out on the job site and kind of left to their own to I'm not talking about everybody either, but there's a lot of them out there that are just kind of left to their own accord to figure it out. That safety and that understanding of this equipment ought to be a daily topic. At the toolbox meetings, you always have new people coming in, and you're going to have some labor rotation, and it's just as important for the old guys as it is the new guys, because quite frankly, I've seen it to where the old guys like me become complacent. I've been doing this way too long for me to not need a refresher, not need a reminder. Complacency comes into play with it, and that to me is one of the most dangerous parts. New people in it, they're kind of scared of it. The old salts like us, we've been doing this so long that complacency is a concern of mine. Daily toolbox reminders are critical.
That is a really good recommendation, is that that crew meeting before shifts, and then obviously continuing to really stress that safety aspect of everything. So now we talked about the safety aspect of the roles of the individuals and the crews. Let's focus on equipment safety and safety accessories that are available to the industrial painting industry. The majority of surface preparation is conducted with equipment that has obviously materials under very high pressure. What safety solutions does Schmidt provide?
Okay, well, we're first and foremost, I want to touch on a safety device that is kind of near and dear to my heart, and it has to do with Deadman. OSHA mandated Deadman many, many years ago for a cause, and that cause was not to enable that blaster to turn a nozzle on. That was not the Deadman's job. The Deadman's job is to turn that nozzle off in a safety environment, a safety hazard. That blaster drops a hose ruptures, he slips and falls. That Deadman's specific job, as mandated by OSHA, is to shut the nozzle down. So with that in mind, there's a fairly broad offering of Deadman in the marketplace. And there's two of them that, quite frankly, bother me. One with style. And what that bleeder style means is that within the body of the Deadman, there's actually a vent hole that's under a handle. And the way that it functions is with that handle up, that hole allows the signal air, the pressurized air coming down the twin line hose, to vent to atmosphere. It's not until you depress the handle that a rubber button covers that hole, therefore no longer allowing the compressed air to atmosphere, so it diverts it back to the vessel and engages the valves. My problem with that style is that there's a natural phenomenon where when you take compressed air and you allow it to escape to atmosphere, that air gets cold. And in certain climates, it will certainly get below freezing. Many of us have seen a ball valve on a vessel released to atmosphere and developed frost on that ball valve. That's that air expansion cooling below the freezing point, taking humidity from the air and creating a frost. The same thing can happen on a bleeder style Deadman. And it's not a matter of if, it's a matter of when. That bleeder style Deadman is prone to that vent hole becoming iced over, and it can ice over to the point where it restricts the exhaust of the signal air and diverts it back to the valves as if the deadman lever was depressed. Nozzles turn on inadvertently. And it's not just ice. I mean, we deal in a dusty environment. There's humidity in there. If dust gets in there, if a hose delaminates, anything that plugs that hole turns the nozzle on. That, I don't understand why anybody would still use a bleeder style deadman just with that understanding. The second deadman out there that I personally have a problem with is the ball and chain. It's a very simple deadman, but it has one valve toggle out that's designed for a thumb to depress to keep that deadman on. Well, that operator out there with one thumb holding that down, that's only one appendage, and that appendage is going to get tired. Therefore, they used to ship them with the valves. My understanding is now they don't. You have to buy them separately. They actually gave you a chain with a wooden ball on it. And its intention was for it to be forced up under that handle, so the operator no longer had to keep human contact on that deadman. He could lock it open, lock it on. In all of the years I've been in job sites out here where they were running the ball and chain deadman, I have never personally seen a SAS cord with a ball on it. Every operator out there had a ball of duct tape stuck up under that deadman handle. So if he dropped that hose, there is no safety involved. That nozzle is not going to shut off. And OSHA actually mandates that human contact is required to keep that deadman on for it to be considered a viable deadman. So the bleeder style and the ball and chain, to me, are two of the largest safety issues in our world. All of our deadman have a mechanical valve in it that shuts off whenever you release that handle. Every one of them. My deadman, my pneumatic deadman, my electric, of course, is an electric switch. Our new pistol grip deadman, those are all designed under the same Generation 2, our G2 deadman, to where we shut that incoming air off mechanically before we allow the air to vent to allow the valves to close. It's just a safer mousetrap. So I just touched on the pistol grip style deadman that we released here in the past year and a half. That was solely for human comfort. You know, holding a deadman down, those blasters, they get fatigued. So we started developing a pistol grip deadman with the intention of, there's a lot of blasters out there running small nozzles, you know, number 3, number 4, number 5s, not a lot of thrust. So putting that pistol grip style was an ergonomical improvement that we believe that the blasters who migrate to them, it will lessen the desire to circumvent the safety system by, you know, taping them down or zip tying them down or something. If you make the operator comfortable, then he's more prone to utilize the safety aspects that's inherent in all deadman, especially the ones like ours that shut off. So the deadman line is a long product offering that we're continually working on. We've done a lot of other stuff. Exhausting of air out of vessels was a major element due to the amount of energy that comes out of these vessels. You know, our bulk tanks, for years, they had an 1 1/4 ball valve that just vented to atmosphere. So when you're at 125 PSI in a vessel and open up a full bore 1 1/4 ball valve, the amount of energy coming out of that orifice was just tremendous. Therefore, the noise was tremendous. So most people wouldn't just go up and flip open an 1 1/4 valve because it was deafening. So we developed our controlled expansion nozzle system that's standard on all of our bigger vessels now. And it does a couple of things. One, it controls how fast that energy escapes and controls how fast it spreads out into the environment. I mentioned earlier on the deadman, expansion of air makes it cold. You can create frost. Well, what we're doing is controlling the rate at which that energy can expand to minimize the opportunity of ice forming inside and holding pressure within that vessel. And then secondly, we manufactured our own silencer for that exhaust system. There is no muffler in the world that we know of that is designed to take the service that will have dust coming through it at 125 to 150 psi. You can't go to a store and buy a muffler and tell them I'm going to run 150 psi through it. They're going to laugh at you. So we actually manufacture our own that we install in conjunction with our controlled expansion nozzle, to where you can safely depressurize our larger vessels. And the noise is going to be somewhere around 92 dBA, which OSHA equates to road traffic, and no hearing protection required, for, don't quote me, but I think 6 minutes. It could be longer, I don't know. But the incorporation of that exhaust system, as simple as it sounds, was one of the biggest kudos to us from the marketplace, because we finally addressed the deafening noise that all blasters with larger units had contended with for years. And we figured out how to do it safely, efficiently, and relatively quietly. On the bulk tanks, the 10-inch closure fill port that was on the top, although the original closure with 5 lug was the safest one that we knew of at the time, if you followed the proper SOP, depressurization, this is how you operate the closure, this is how you open it, etc. There were some safety, what's the word I'm looking for? There were elements of safety incorporated into the original design. The problem is that not everybody would follow proper SOP. They didn't depressurize the unit right. They didn't follow instructions on how to open that closure. So a few people opened closures under pressure, and bad stuff happened. So what we designed was our HALOK closure safety system. And what the HALOK simply does is it mandates that the operator follow the original standard operating procedures for the 5 lug 10-inch closure. It doesn't allow you to drop the bolts out until all 5 handles are down. And as long as all 5 handles are down and the bolts are still in the lug, God forbid there was still pressure in the vessel, but if it was at that point where all 5 handles are down, therefore the tension is off of the bolts, the gasket is gonna release air and scare that operator up there saying, I'm in a bad situation. The HALOK simply mandates proper SOP being followed on the original 5 lug closures. We have had many responses from the field where safety incidents have been averted because of the incorporation of the HALOK system. It is truly one of a kind. And other people out there have developed these clamshells that simply wrap around the 10-inch 5 lug closure. Well, hey, kudos to them for doing something. But in our view, all they did was added one more step to the standard operating procedure, that if the standard operating procedure was followed, they wouldn't need the clamshell. They wouldn't need the HALOK. So the addition of a clamshell, once you take it off, you still have the same 5 lug closure that has caused safety incidents in our industry. So I'm not a fan of the cam locks. It added something to it. Okay, I'll give them that. But it doesn't force them into following the proper SOP like the HALOK does. And of course, we've done a lot of other stuff here. We actually have a short-proof electric deadman system, and this is pretty neat. Where its design came from was the fact that we realized that there's a lot of people in large blast rooms, running 200 and 300 foot of blast hose that were running pneumatic deadman instead of electrics. Well, a pneumatic system at 200 and 300 feet is way too slow for us to be comfortable. But the reason that they went to pneumatics was they were scared of an electrical short, dragging their cables on the grading of the floors and creating a short. So we developed a short-proof deadman system where if a short occurs, our control box will not recognize that as a signal from the deadman, and the deadman will not engage if there is a short. At the same time, if you're in a blasting operation, your deadman is on. If a short occurs, it turns the nozzle off. I'll try to get a video to you that kind of shows this in a little desktop like we have. It's really a unique system for those people wanting to run longer runs with a high level of safety. And there's a lot of other things we've done, but those are the big ones that I feel we should discuss today.
Yeah, I think that the HALOK system is the most impressive that I've seen, and I've had a couple opportunities to witness it in operation. For the viewers, I will make sure that I have links to videos that Schmidt does have on their website. I will have links in the video description on the different accessories and products sections on the Schmidt website as well. Bill, what a great conversation we're having related to this topic. In closing out this episode, is there anything that we didn't cover that you would want to leave with the viewers?
I want to retouch on the fact that working knowledge of the overall system is way too often overlooked. New hires, old hires become complacent. This topic, because it is so dangerous, needs to be on the forefront of everybody's minds and regularly at that toolbox description. Daily checks of the system a lot of times is overlooked. These vessels last a long time. They do. I've actually worked on the very first vessel that Schmidt Manufacturing made with their own ASME stamp, and that was from the early 80s, and it's still in play today. But they regularly look at that for corrosion. They regularly look at that equipment for any physical damage, a dent, a crease in that steel. This equipment is durable, but it's not invincible. And the system should have a regular visual check, documented, corrected, fix it. Don't allow damaged goods to remain in that field, because that damage might not be a hazard today, but it certainly can be tomorrow, next week, next month, next year. So these operators, that's part of their responsibility. Make sure that system is in good, sound, solid, operable condition. Teach them to look for air leaks and not accept it. That air leak is not going to fix itself. All it's going to do is propagate. And not only are you losing energy, but you are creating another safety hazard. People walk by an air leak and it hits them in the eyes. That's just intolerable. I don't get it. Safety cables. To be honest, Jim, I refuse to go around a live unit without safety cables. I've been hit by hoses. I've had Chicago fittings fail. I have the scars on my legs to prove it. I had a salesman. He wasn't young, but he was kind of new. And I took him through all of this, and he didn't abide by my warnings, and he had to learn the hard way. And he went out to a job site doing a troubleshoot, and a hose failed and it hit him in the leg, and he ended up with 16 stitches. I won't go around a live hose without the whip checks. It's just cheap insurance, guys. Make sure all those workers understand the inherent dangers and the safety components of each unit and how to properly pressurize and depressurize the units. Accidents happen too frequently because either one, they weren't taught, or two, they become complacent. Keep that discussion at the forefront.
Bill, I appreciate you sharing that in the closing here, and also the experience that you have. You've been a great help to me when it comes to a lot of the technical information related to abrasive blasting equipment and topics like this. Thank you so much for this opportunity to have a conversation with you today.
Always a pleasure visiting with you, Jim.
Hey, have a great day.
You too, buddy. Talk to you soon.
I hope you found this episode very informative. If you have any recommendations on technical topics or if you have any technical questions, please see my email in the video description. Please like and share this video, and if you're not a subscriber to my channel, please subscribe. It's easy. All you need is a Gmail or Google account and hit the subscribe icon. And remember to set the notification bell to all so that you won't miss any of my new content.